codon. Every gene you have should start with the start codon. And you keep breeding the thread. So every time you see a thymine, adenine, guanine, cytosine, then down here with adenine, it would be uracil. So you there's eventually a stop triplet, and that would cause the RNA molecule to stop being synthesized. Okay, so this is messenger RNA with the junk, right? We don't want to keep all the junk. So you're going to see some of that molecule be removed. So this large section that's fixing to disappear right there, that was junk. We don't want to use that. And then you glue it back together, and then we only keep the parts you want to use. Okay, now the messenger RNA is coming out of the nucleus. You're going to see the ribosome bind to it. So it reminds me of a hamburger bun. So my top bun, my bottom bun, and then the RNA is going to be sandwiched in the middle. So again, this is my design or my directions for the protein. This is the construction site or the printer. Okay, and these are my dump trucks, the transfer RNA. So on one end is the amino acid, and then on the opposite end is the complement that matches the codon that's inside of the ribosome. So the first one, AUG, is right there. So that was my start codon. This is my second one that came in. And then when it shifts, you can see what's in the last spot gets pushed out. And then this spot here is going to be freed up. That one just came in. So that was my free spot. One came in. This one gets pushed out. And notice the codon. So that one's AUC, GAA. The next one's UGU. So if I go to my chart, I can figure out what amino acid it's going to be UGU. Then up here, the amino acids are jumping from previous to new, previous to new. Now, it doesn't show it, but the last thing that comes in is the stop codon. And the stop codon actually brings in water when we hydrolyze. Hydrolyze means to cut with water. And then everything detaches and the protein forms. Again, it's pretty quick, so I'll run it through without stopping. Okay. So you can actually mass produce proteins. That one messenger RNA, it can be used over and over again. So as you run it through one ribosome, when a little section is enough for another ribosome to grab a hold of it, another ribosome could be running a new protein while the old protein is trying to finish. So you can mass produce proteins kind of like an assembly line with one messenger RNA. Okay, are we good so far?
I'm good.
Okay, so
Thank you.
I got some practice problems. I'll help you with the first part, and then I'll have you finish up the other three during the week. Let's see, where they hiding at? They're gonna be in this folder. And again, I will bottom. How do I want to do this with y'all? Because I can't do it on the board. Just copy this. Okay. So what I have here is strand A, strand B, strand C, and strand D. These are all DNA templates. So we're going to first convert them over into RNA with the transcription process. And then we're going to figure out the codons. And then we're going to use the codons to translate that into a protein. Okay, so don't get confused by the 5' and 3', but the way that RNA is created is in a 5' to 3' direction. So if my template is 5' to 3' for strand A, that means what I'm creating has to be the opposite order. The 5' is actually going to start down here. Let's see. So 5' would start right there. No problem. 5', and then it runs in that direction. Nope. That direction. Come on. It's so much easier on a board. Okay. So we're actually going to start with this and run in the way the arrow is pointing. Okay. So if I was to start with that triplet, my codon order, it looked very kind of similar. Okay, so T is my first thing. So bring in a adenine. A is my second thing, my second nucleotide. That brings in the uracil. And then C is my third. It's going to bring in a guanine. Oop, right there. To bring in a guanine. So like I said, every gene out there starts with AUG. So you know you did it right if your first 3 letters are AUG. That makes sense? Okay, so that's our next one. So that's going to be an A. And then it's going to be CC because I have GG. So I'm here now. That C brings in a G. And then we have GT, so that's going to be CA. Let's see, that was that one. I'm on that G now. So it's going to be C, and then it's going to be AU.
CAU.
And then finally we have UAA.
Stop. Aku pasti yang paling awal ya, Bang ya. Aku selalu awal, UAA pasti yang stop. UAG itu kalau nggak salah di tengah-tengah ya, mid yang kedua. Yeay. Nah, begitu caranya transparansinya. Aku mau coba. Jadi RNA karena ada U-nya.
Underline these. So each section that I'm underlining is a codon.
Nah, itu tiga-tiga itu namanya kok.
So this is my strand A, and then these are my codons produced by transcription. And then if I go down, I have a codon chart. So my first codon is going to be AUG. So again, that's good because every gene should start with AUG. So I go down here, I find AUG on my chart, it's the green one,
Oh.
and then the MET is the type of amino acid, it's methionine. So I go up here, and in my blank for number 1, I write MET. So that is the amino acid that's brought in. Okay, my second amino acid, or my second codon for the amino acid is ACC. So I go down to my chart, find my A's. So here's my A's row, and then I want CC. So I go through there. It's right there. We see it, ACC. So that means I'm bringing in thymine. So I would go up to my blank, and I would write in thymine, THR. Okay, we're on the third codon. So GCA, go back to my chart, GCA. Okay, the bottom row is my G's. Then I want CA, it's right there. So if we go over, that is bringing in alanine, ALA. ALA. My fourth codon is CAU. Go to my chart. CAU is right there. Histidine. And then my final one is UAA. And if I designed it right, I know that all my proteins should end with a stop codon. So UAA is one of my stop codons. So I would go up and I would put stop. Did everybody see that? Or good with that? Okay, so I'll put this in our chat. You can work on this through the week, and then we'll go over it next week. Sound good?
Okay, good.
That is great, guys. I think this is very, very important stuff. Okay,
I'm muted. Hang on.
this is very important. Okay, so better for you guys to understand this now. Remember, okay, this is a very high class. Okay, very high quality of lectures. You do not want to miss this. Okay. Thank you, Prof. Ken, to
You're
help
welcome.
them to understand.
Yeah, so this is a pretty heavy lecture. I don't want to go into much more. I'm going to give you this in the chat, and you can practice it. If you have any issues with it, you can email, or you can put it in the chat, and I'll try to answer as fast as I can. Next week though it'll be cool. We're going to look at chromosomes, how DNA is structured, and then we're going to go through the process of mitosis. So mitosis is how you copy your DNA. Okay.
Yeah, I think we can go slow until they really understood this. I mean, this is the core of this sequencing, the DNA. Okay. So, guys, all right, you try to understand this. I know it's difficult, right, Nicole? Your mom said, you say it's very difficult. Yes, it is difficult. Nothing is easy. Okay. But, but, okay, the differentiation between those who give up because of the difficulty and those who keep going will be proof in the long run. Okay, those who keep on going, you will be like a leap. You leap, okay, even 6 or 7 years ahead of those who say, "Oh, I cannot make it." Now remember, okay, we have Michelle Tang here. Okay, Kak Michelle. She will be doing this kind of stuff. All right. Now, let me ask Michelle. Michelle has been admitted to Colorado University at Boulder, okay, in bioengineering. She will study all this stuff, all right, and then become an MD, medical doctor. Now, Michelle, are you in there? Let me ask you this question. Okay, this is a testimony for you to talk to everybody. All right, the question is simple. Have you, okay, or after you finish high school in the next maybe 3 weeks, you will be done with high school. Have you guys or have the student in your class learn about this? Go ahead, Michelle. Talk quite louder. Okay, respond
Okay,
louder.
so what just Prof can tell us? Well, we did study about genetics in our last year in 12th grade. Yeah, we only study about genetics in 12th grade, which is in the second semester, and we haven't really studied much about genetics since, well, our class ended. It's only about the glimpse of it. It's just not really profound totally.
It's very simple, right? Not this far, not this deep, right, Michelle?
Not that deep.
Yeah. Okay. So what does it mean, guys? Okay, you are leaping. Okay, even Kak Michelle, who got admitted into with the bio engineering, never have this go this far. So think about Alfonso. What will happen when Alfonso will apply to the U.S. university in the next 6-7 years? All right. So we are talking about Harvard here, guys. All right. We are talking about MIT. Okay. This class will help you to get through. You know why? It's very simple. Human, okay, have a lot of trouble, a lot of challenge. Okay. So, like I said before, all right, Professor Ken and I cannot come back and do some research, okay, on this. The only thing that can do it, the young people like you. So we recruiting, okay, we'll be preparing you, we prep you, okay, to be a future doctor, okay, future engineer, so that you can do something good for humanity, okay? Now, if you do something good to humanity, what it means? It also do good for you, for your future, okay? In terms of whatever it is, for sure your income will shooting up like crazy. Maybe you make a lot, like $1 million, okay? Basically, maybe, in a year, okay? Professor Ken and I never will make $1 million. We are done, okay? But remember this. Without Professor Ken, without your teacher at school, okay, without TIS, you will never, okay, you will go that direction, but it may take time. TIS make it simple, make it faster for you to reach that goal, okay? Now, if you can see this, unfortunately, okay, if you see this, Professor Ken is all female. Is okay, except for Alfonso. Alfonso is still grade 4. Okay.
Wow.
Grade 4. His mom is here. Okay, Mom Okta, to help him to understand. She already taking like 7 or 8, I think at least 5 classes from TIS, Tutorial International School. All right. She may not have time, maybe not have the idea, but look, okay, his mom keep going, help him. That's what we need. And the other mom say, oh, I too busy. Okay, I don't understand English. So you see that progressing, okay, all this keep progressing. It's progressing, and all the parent is finished. Okay, the parent not even know what they're talking about. All right. Now here we have Finca. Finca is from the remote island. It's very far. Okay. Now Nicole, Finca has all this. Okay, and Honey. Okay, Honey has been with us forever. Okay, she just keep on going. All right. So with that in mind, I think Professor Pence, we are thankful, okay, for all this opportunity. Okay, so let us go slow. Okay, let them understand how to do the sequencing. All right, and then we go from there. With that in mind, I pass it back to you, okay, Professor Pence. Thank you.
Okay. So we can we can try this again next week. We can go over the problems that I give you for the week to work on. I can make some more of the assessment questions. Did y'all find those useful? Did y'all get the right answers?
give them a lot of assignment. Okay, it's not easy. Okay, maybe they
Yeah.
grab a set one, but there's no consistency. All right. Now give them a lot of assignment. So that they will be, strengthen the background because it is not easy. It's not easy, guys. Okay, but keep on going. All right.
Yeah, but learn from your mistakes is the best way to learn.
If you have any question, anybody, okay, do not shy to ask. All right, do not shy to ask. Ask whatever it is. Okay, we are here to help. All right. Now, Nicole, did you grasp the idea about all this sequencing? Okay, do you see that? Okay, A, B, 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 C. All right, maybe uh, can put it again. Okay, that screen, ABC, all of that kind of thing. Okay, now which part that you don't understand? Okay, there's no way by attending one lecture you will know all of this. All right, let me ask Michelle. Okay, Michelle is the standard. Michelle, by
Sir.
looking at what Professor Pant show, okay, would you be able to do the sequencing for other problem that have been given by Professor Pant? Would you?
The DNA and RNA sequencing, sir?
Yes. The one that, Professor Pant put it over there on the first one, okay, with the red one, CAG, okay, red one, the CAG. Remember
I'll
that?
go back to it.
Yes, that one.
Uh,
This one.
yes, yes, CAT,
Yes.
yeah. Okay, let's
Okay,
take the 10A 5-inch and then on the other side is blank. Okay, that sort of thing. All right. So do you understand all of this concept? Okay. What are the difference between the left one and the right one? And the last one, B3. Michelle, do you know?
I'm using my phone. I'm currently trying to zoom the picture. Hold on. First, how can I zoom this first? Okay, so I think based on what I've learned from my school, I think that there are a few here. Hold on, just type right here. Hold on, straight D is this DT.
Yeah,
I
don't
think the
worry
one is
if you do
strand
not.
B. It's something.
Yeah. Okay.
Yeah. Oh, hold on. Strand B. I think the strand B and the upper one is like sense, and then the lower one is antisense. And then for the one with U, I think it's USO, which is in the RNA, which is an RNA code. I think that's based on what I've learned from my school. Yeah.
Okay. All right.
So
Okay, guys.
just make sure that the 5' and the 3', so that little what he called inch apostrophe is meaning prime in this case. So 5', 3'. 5' is the beginning of DNA or RNA, and then 3' is the end of DNA or RNA. So if the strand A and strand B is DNA, it says right here. And then over here, I'll put this in different color. Let's do this in like on a blue.
Mhm.
So the blue is what we changed over into RNA.
RNA.
And then the 5 here is showing you that this is where you start to turn over into RNA. And then the arrow is how you would move. So you would start there with that T and you would go in this direction. So on the bottom one though, it would be a little different. Since my 5' is on the opposite end of the other strand, I actually would start here at this T. Oops, wrong. And I would go in that direction. I would start that T and I would go in this direction.
Okay.
Yeah, so it does have a beginning and an end in the correct pathway.
Right, right. So this is the start, how to read it, okay? How to read it. Okay, we're still far away, but okay, whatever that we do this morning, it's very important that is a basic, Okay, lay the foundation to move on. All right. Make sure, guys, you know every bit of it. Okay. Now,
The
this is
way
good.
the way I have
Yeah.
this one designed is that you're correct if you convert it over an RNA and it starts with the AUG, because that's the only thing it can start with. Every gene out there does. And then if you finish, you should finish with one of the stop codons. And if you go down to the chart, your last codon should be one of these red ones. And you did it right if you have the green one first and the red one last.
Mhm. Mhm. Yeah. 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 I'm so lucky today. I have time and then come back and join this group. It's very important for me. I also learn. Okay. And most importantly, okay, this lecture has been recorded. This is very important. Otherwise, we miss all this important stuff and you cannot come back. Now, we will put it, on the YouTube channel, okay, TIS YouTube channel, so you can come back, all right, and try to understand and read it again, again. Watch it again and again, all right? So you have a great future, guys, very great future, all right? Now, think about it. Look, okay, Professor Pence got all this stuff from his private collection, lecture collection. TIS do not have it. You see that? Okay, what does it mean? It means only those, okay, only those professors, only those people who would like to, have a genuine interest to help you will come over here to share the knowledge, okay? Like I said again and again on the first lecture, all right? This is 8 a.m., 8 a.m., okay, in the US, okay? And Professor Pan have his time for you, okay? Now, let me ask this. Ibu Okta, you can speak in Indonesian or you can speak in English. What do you think? You learned this when you were at college. Is that correct?
Yes, I learned it while I'm in the college.
Okay. What grade? What your area? Your area will be in biology. You want to be a doctor in the past?
No, I'm a bioengineering master biology actually.
Okay. Do you?
Oh,
Yeah.
I just remind myself of this basic education.
Okay. Now, okay. You work full time as a mama, right? Now you can pass that dream to Alfonso. You may not reach what you are dreaming to be a doctor, to be a scientist, whatever it is. Now you have a chance to pass it to him. Okay. This is a huge and tremendous. When you went to the university, the college, many years ago, all right, this stuff maybe is not even exist. Okay. This advance only in general term, like Michelle said. They learn about general things because the curriculum in Indonesia did not require only follow the curriculum in Indonesia, you cannot basically compete. Okay? You cannot compete. We are talking about what? We are talking about the global competition. Okay? Global competition to get into the US university. All right? What are they? Okay? All university that the biggest. Okay? This is the problem. We learn. We learn just of initial time, okay, to be admitted into all big school, okay, Harvard, Yale, MIT, okay, Princeton, okay, Indonesian curriculum, okay, will not be able, okay, to let their student to get admitted. Zero possibility unless international school, okay, like the one in Serpong, the one in BSD, okay, like that is the only chance. The only thing, if you are from small school, Santa Lucia and all of that, there's no way, okay, unless you follow TIS, program, they will give you opportunity, okay, to be admitted into this big school, okay? So we learned just now, okay, from Michelle Tang cases, okay? If you are not ready, or the curriculum is not even there, we are not going even to look at you, all right? So English is important, but not just English, okay? You have, we are going to, that what lack of it, okay? Because the students are not ready, okay? Now, if it is 2 years later, okay, if we have 2 more years, Michelle will be different, okay? The admission outcome will be different, okay? Why? Because we miss like so many things, what we call it AP, advanced placement, okay? They don't have it in Indonesia, all right? Unless you want to go to UI, okay? If you want to go to UI, guarantee after you attended TIS program, you will be admitted. Okay, sorry for that. Professor Ken, we have 1 more minute.
I'll say I did share the practice with the group, so they should have access to the rest of the problems now.
So we do not want to take more time from Professor Pence. Okay, it is exactly 8 o'clock. Do you have any question? The last question. Okay, otherwise, okay, I stay here. I would like to talk to may leave, whatever that he decided, okay, but let me like 5 more minutes to talk, okay, and that will be off record, off recording. Now, okay, I'm going to make it off the record, okay. All right, let's see.